Hello. Okay, this is my first time using this. I hope it works okay. Right, let me change that a little bit. Looks a bit blurry, but it's all right. Okay. I'm just going to give it a couple of minutes because I started a few minutes early. But if anyone is in the stream now, they can write me a comment. People should be able to comment. Yeah. Hello to people who just joined. I'm just going to give it a few minutes. By the way, if people ask questions in Persian, I'm going to speak in Persian and probably translate it back to English. So I might say a few words in Persian as well. Durud. Okay, I'm just going to give it a try to see if I can wipe the camera. I don't think this is the camera issue, but I'm just going to give it a go. No, I think it's just a YouTube thing. We will start in 2 minutes. Okay. Right, it's officially 6 o'clock, so I'm gonna start. Hello and welcome to the channel. My name is Castro. This is a live Q&A session about the machine I'm building. I'm gonna say a few words in Persian as well for people who are Persian speakers. خب سلام به دوستان. کسرا هستم. خوش اومدید به کانال. من صفحه‌ام رو به اشتراک میذارم و اینجا اگر سوالاتی دوستان دارن میتونن بپرسن. اگرم که دیدیم که خیلی سوالات زیادی مطرح نشد و خیلی افرادی نیومدن میتونیم کلا لایو رو قطع بکنیم. Okay, let me share my screen. Okay. So, what I've been doing recently is I've been designing the sort of enclosure of the machine and also a few bits and bobs inside. The big surprise, as you can tell, and as some people asked, was regarding the automatic pallet changing system. So let me just get rid of this dummy first. Where is it? There we go. So initially, I thought that I will put a robot next to the machine itself and then have like an automatic door to open and close, and then the robotic arm can change the pallets inside the machine. But then I realized that, yeah, that's a bit of a dumb idea. So I thought, let's change it a little bit. And what I did was I designed a pallet changing system inside the machine and designed an arm which is mounted next to the spindle for changing the pallets. Okay, so I'm just going to say these things in Persian as well quickly, and then feel free to ask any questions as we go along, and yeah, just pop them into the chat box. درود به دوستان فارسی زبان. این بدنه بیرونی دستگاه رو که چند روزی هستش طراحی کردم برای این بوده که بتونیم اولا یه ظاهر شکلی به ماشین بدیم و قبلا قرار بود که یک رباتی این کنار دستگاه باشه که بعد این رو کلا حذفش کردم و الان سیستم تعویض پالت با خود دستگاه انجام میشه. Right, back to English now. Okay, so let me just get rid of this enclosure first. There we go. Okay, so this is the pallet changing mechanism. So the pallets are stored on these racks. If you can see, I think, yeah. So the pallets are stored on these 3 racks, and the whole racking system is mounted on a couple of linear guides. And the linear guides can rise, well, the whole rack can go up and down, basically, like so. And next to the spindle itself, I have mounted a pneumatic rotary actuator, which is that part. And then there's an arm, and then there is a gripper that grips these pallets. So the idea is that if you want to change the pallets, what you will do is you would use pneumatics to rotate this arm. Let me just demonstrate that quickly. Okay, I will change the angle to 0. That should work like so. Got a question, why position the arm there? Okay, yeah, that's a good question. So I think I tried multiple variations and different things. So the first idea was to have like a Cartesian robot above the machine itself to pick the pallets up and put them on the chucks. But then that would add complexity. It's more expensive because you're adding 3 or 4 different axes, and you already have a 3-axis machine. So why not just use that? I tried to simplify the whole design by just putting the arm next to the spindle. Now, originally, I wanted to use there are some systems that you can find which are for changing the tools on a robot end effector. So basically, a robot has one part to the mounted on the end effector, and then you've got multiple tools that this robot needs to go and pick them up. And these have some sort of interface, which is pneumatics. So it's like a mini chuck that goes in there and then clamps the tool, and then you can have multiple air and electronic channels for the tool to operate. The idea first was to mount this arm like in the position of one of these pallets, and then have one of those interfaces to couple and decouple the arm, which is kind of okay, but because you are adding a lot of these connectors which are open to the elements in the machining area, they can have some chips on them, they can wear out, they can there's so many problems that can happen, and prevent the system to work seamlessly, automatically, unmanned, which is the idea of having a pallet changer in the first place. So by adding this rotating arm, I prevented that issue in theory. So the arm is mounted next to the spindle because we've got a 3-axis machine already. So the sequence is, let me just get rid of the tool changer. So this is my protection guard, which is polycarbonate plate that goes around. And as you can see, now the arm is interfering with the polycarbonate when you are machining. That's why we've got the swing thing that moves it away from this polycarbonate. When it goes up, then obviously you've got enough clearance to move around. When it's down, with a couple of steel wires and some pulleys that you can see up here. There's a pulley there, there's another pulley there, and another pulley there. In the end, I will have like a linear stage that sort of pulls these wires, and then the whole thing would get raised up. So this will go up, which is our pallet changer. It goes to first position, which is right around here, a little bit further up, maybe around here. Then the arm comes down, goes around it, boop, grips. This is the largest vise that I can fit, which is, I think it's way too big for what I need. So that's the system, like so. It grips the pallets, picks it up with the spindle, goes all the way back. The key is that the point is that you have to drop your tool first before starting this sequence. Otherwise, you will have some issues. And this will go down like so. Puts it in the chuck, well, a little bit further back, but you got the idea. And then goes up, and then rotates, and that's about it, really. It can also drop the parts onto this fixed position. So in an ideal scenario, you would do your roughing here, where you've got a fixed 3-axis machine with a table, if you like, which is quite rigid. So you're not putting pressure and tension on the bearings and wear out the bearings on the 4th and 5th axis. And then when you want to do your finishing, because these pallets are quite repeatable, well, it's from System 3R, they should be repeatable to better than 5 micron. So you can pick it up from here, place it here onto the second chuck, and then you do your finishing job. And then once it's done, you store it in the magazine or in the pallet changer here. So in this scenario, I could fit 15 pallets and 28 position tool changer. So that should keep the machine running for a few hours unmanned at least. Obviously, it depends on the cycle time of each part, but that's the whole idea. So this comes up, and then yeah, it goes again like so. What else I did recently? So that's the pallet changer. Spent a lot of time to get the distance between this and the stroke of the machine just about right, because now, as you can see, when I move this down, the clearance here is about 2 to 3 millimeters. I can't make it smaller, I can't make it bigger because I'm quite limited on the stroke of the machine axis. And 5 pallets in each row is the maximum number that I could achieve. These are quite big vices from Lang, so the manufacturer is Lang. This is the largest one I think I might need for this machine. It's also quite tall, and I've added an adapter plate as well. But I know System 3R produces a vise which is a lot more compact, and you don't need the adapter plate. But I just wanted to have the biggest, bulkiest possible vise and setup, so that I can design around that. And obviously, and if anything is smaller, then it's a bonus for us. So that's the whole idea of the pallet pool and the pallet changing system. So it uses the whole machine itself, not adding much weight. The whole thing weighs about 2.2 kilograms. This whole setup, I think, this is like 1.4 something or 1.2, and these plates and the arm and this and that, I think it's about 2.2 kilograms of added weight, which is, for this huge motor that we've got, it's absolutely nothing, peanuts. So I don't think there would be any issues, and I don't need to change anything on the machine itself. I just need to make this one plate out of aluminium. It will get bolted on the spindle, and then just one plate on the side to support it, which will be laser cut and then gets mounted on the exact position of the Z-axis cover, and that's about it really. And then this one arm and a couple of fingers. So it's relatively straightforward. And then I designed these pallet holders as well for System 3R, which are again quite simple to make. Now let's talk a little bit about the enclosure first. So this was the big surprise. I hope people have enjoyed it. Now back to the enclosure. So the enclosure is from 80 by 80 aluminium extruded profiles, like so, as you can see. I will be mounting the 3 chillers that I have, one for the spindles and the spindle and the C-axis and A-axis. The other one is for the whole moving axes, like your ball screws, like your linear guideways and so on. And the other one is for the coolant. And inside, underneath the tool changer, which is right around here, I've got a big space that I can put a small in-cabin AC unit. So like a normal household AC unit, which will get rid of any moisture inside the machine. I'm not sure if I would need a mist collector at some point. I might not need it because I don't generally use a lot of coolant on this machine, but if I need it, I can place a mist collector right around here. That's why I've got this space reserved for it. If not, then that AC unit can do the job. And then at some point I will add like a cutout for all the interfaces, like the hoses and like the cables and everything that needs to go through the enclosure. So this is a double glazing system. So all of these panels are like 2 panels. So this whole enclosure is double glazed. And then I will put a rubber mat underneath the whole thing, which hopefully will kind of make it as airtight as possible. It won't be completely airtight, but as airtight as possible. And then this whole sort of back rear panel, it lifts up with these 2 handles, which are about 1.23 meters apart. So you can easily get them, and you raise it up, and then it will just come loose. And between the 2, I will again have a rubber sealing. So when you put it there, it just goes like on this angle, it goes down, and then it just creates a seal. by just the weight of it. And then this is also double glazed. And on the front, I will have like two double glazed windows. So one goes down, so you've got access to the table. Obviously, this won't be up here. It will be down there, like so. So you can have access to the insides of the machine, change a part, do whatever you need to do, some cleaning and what have you. And then when you want to machine, obviously this comes up. It's just manual doors, and then that's it. If you want to change pallets, you can either open this one up, and you've got access to the to the pallets, or you can actually ask the machine to bring the pallets up, so you've got access like right in front of you, like here, because that's another servo controlled access. So it's relatively straightforward. And also, if you want to change the coolant, this needs to go up a little bit, or if you need to do some maintenance on the coolant tank, it comes up as well, and then you can pull this out. So you've got full access to this one too. So that's the whole access situation. I hope I explained it okay. I've got one question in the chat. I'm sure you've calculated everything, but would there be any interference that might arise from having the arm shaking around whilst it's rotated upwards? That's a good question. So I don't think so. It won't be shaking because it will have air always, like it's always on. So this is not a spring system. This is just like an air on and air off. So these are like you've got two air inlets, one for swinging it like clockwise, the other one for like anti-clockwise, and the air always needs to be present there. So when you've got air on one side, it's pushing it against the hard stop, which is inside the mechanism itself. So it's always like preloaded with a lot of force, so it won't be shaking around. And actually, I selected a model that can go beyond 180 degree, so that the resting position would be at like 170 degree, if you like, or 190 degree. So basically 10 degrees past the dead center. So if the air gets unplugged or what for whatever reason, just due to gravity, it will not just go backwards. So it will just stay there as it is. So that's the whole idea of having it rotating over 180 degrees. Like so, I can show it to you. I think you saw it first, but I'll show it to you again. I think it's this one. Like 170. Okay, it should work now. There we go. So this is now past like 180. So if air gets unplugged, it will just stay here, just due to the weight of itself. But then, yeah, when you rotate it down or when you rotate it up, you've got air always present there, and it's like quite rigid. Yeah, I'm excited to see parts coming off of this machine too as well, hopefully at some point. Let's see, let me just get rid of the enclosure again. So if now this goes up, looking at from the side, as you can see, if I go all the way down to the minimum point of the z-axis, which is like these two plates seeing each other, you can see that I've got way too much clearance now for the system to do its job. So I can just go all the way to the front, which is right about here, and I've got about 3 to 4 millimeters of clearance between the glass and the arm. So that's the maximum stroke of this axis, the y-axis, which I call it. And yeah, that's about it. So when I go all the way to the left, which is right around here, I can pick this pallet up. And then when I go all the way to that side, which is just around here, I can pick that pallet up. So that's why it's a little bit off center, and I can't add anything more to the left and to the right. And that's why we've got like 3 rows. And 3 rows is the maximum that I could fit inside this area, because if I put another one up, then it will interfere with everything. So this is sort of the maximum of the maximum. I can't really do anything more than that. So 15 pallets, which is plenty. And yeah, and it's simple because what I've added is just a swinging mechanism, and that's it. And this is the standard part which you purchase. This is a model from SMC. I'm not sure if I'm going to buy it from SMC because they're quite expensive, but we'll see. And then, yeah, when you are also like changing the tools, this does not interfere with anything. So this goes up as before, this comes back down, and goes over here. And then the tools are changed right around here. Oops, sorry. Yeah, just around here, the tools gets changed, and this does not interfere with anything. So that it doesn't interfere with anything of the machine's work, and also it's quite lightweight, so it's not adding any sort of unwanted weight. Yeah, still adds a lot of unattended runtime. Yeah, exactly. That's the whole idea. So by combining the 28 pocket tool magazine and the pallet pool, you should be able to run, say, for example, if each job needs 5 to 6 tools, plus you've got a couple of reserves for like your probe and a few other bits and bobs, you can have like a family of 4 or 5 tools. And so you can have 5 families, like 5 sets of tools, which you call it sister tooling. And say, for example, each set of tooling lasts about 3 parts. Then you've got, with like 15 parts, you've got 5 family of tools, and then you can cover the whole thing. So every 4th part you would go and change, and you would call a sister tool. So you can say, okay, so this tool lasts about 3 of these parts, and after that it goes on the like it goes on the size, or the life ends, and we need to change it. And that's how you plan it, and you've got all of the interfaces and the control system to do that sort of thing. Yes, yeah, that's a very good question. A camera will be added. I've got these 4 holes which are what you call them, like tapped. I will add a camera at some point around here, something that does not interfere with any of the machine's work. Obviously I will have a coolant system around the spindle, which I haven't really added, but I've got it actually, but I have not added it. But yeah, the camera will be mounted around here. Funny you should ask that, because if you look at the control panel, this is a newer version. I wanted to buy from a company like a standard control panel, but then I thought, you know what, I don't really like that. So I went and designed this thing myself. It's not finished yet, so the design is not finalized yet. I don't think I'm gonna like. I don't like that this sort of handle, but I'll probably change that. But it will look like something like this. So this is a 24-inch touchscreen monitor, and the touchscreen is like corner to corner, so it doesn't have a lip. So it's a flat screen, which is completely touchscreen, and also it's a glass screen. It's by a company called Iyama, which is a Japanese manufacturer, and it's mounted on friction adjustable friction hinges. So when you rotate it like so, it will stay in place, but you have to put some force behind it to move it around. And once you've done that, then obviously you've got this. Now underneath, I've got a second screen. So this is a screen. This is not just a keyboard. So this is a second screen, which at this moment it's just showing a keyboard. So if you're typing something, you've got a touch screen, which is a keyboard. But one of these buttons, if you push it, I will have an HDMI switch underneath. When you push that, it will show the feed of the camera. So by just pushing a button above it, boop, you go to seeing the camera, because you don't need the screen all the time, and you can have also, you don't need the keyboard all the time, and you can use that as the feed, and you can also have an on-screen keyboard up here as well if you need it. But then when you don't need the camera feed, you just click that, and then it goes back to being a keyboard or whatever data you want to show. So it's a dual monitor, dual touch setup, and this will have this can rotate upwards as well if I can do it. This is a bit clunky, sorry. Let me just pin that. Usually works when I pin one of them. Okay, like so, yeah. So you've got this, again, same sort of hinge setup. You have to firmly pull it up, and then it will stay in place by just the friction on the hinges. And then you can type, do whatever you want, and then when you're finished, you can just like rotate it down like so, goes back down, and then you can rotate this back to where it was. And now it sits flush with the machine itself, which is very good for my OCD. As you can see, yeah, very satisfying. So this is completely flush with the machine, and nothing is protruding above the the teach pendant, or the MPG rather. But that's you can forget about that. Right, I was about to say typing vertically. Yeah, this is 45 degree, so it comes up 45 degrees, hinges up and tilts up, and you can just like type. Obviously, you don't really need to type on these machines to, you know, that much, but you might want to add the odd number and push the odd button, so you can use it like so. What else have I done? Not much really. The rest of the system is pretty much, obviously I'm halfway through the build, so I can't really do much. I can't really change much, but what I will be adding is I'm going to add a secondary mini control cabinet, like electrical cabinet. On here. So I will have a small control cabinet here. And because there's so many IOs up here that I don't really want to like wire it all the way down to the EtherCAT connector all the way down here. What I will do is I will have another EtherCAT module up here, and then just a 24 volts, and then all of the solenoid valves for the spindle, these mechanisms that swings and then grabs and then opens, and all of these sensors and everything, they will go just around here. And also I probably can actually bring the encoder for the spindle also into this box. So I will have a small electrical box here with EtherCAT cards, and then I will just have one Ethernet cable going all the way down to the other EtherCAT module, which I will have here. So yeah, that's about it really. And then this one, which is where the filters would sit, this will change direction. Now it's facing that way. It will face the other way. So when you open up the rear door, you can access the whole filters. You don't have to go all the way to the other side, which can be a little bit uncomfortable. No plans to adding a chip conveyor. It doesn't need a chip conveyor. It doesn't produce a lot of chips. Therefore, it doesn't need a chip conveyor. This is mostly a finishing machine, so I would say that most of the parts will come off of another CNC machine, which has been like they've been like roughed, and then this is just like to do the high precision finishing. Or if you are actually removing chips, you're not creating loads and loads of chips on this machine, so it will not need a chip conveyor. The whole idea of having a chip tray like this is that you can pull it out every now and then. And if I can show you what goes inside, there we go. So you can see like I've got 3 or 4 different levels of filtration. So most of the chips will get accumulated on this first one, and then water goes from that side to the second channel, and then the third channel, and then the fourth channel, and each time the chips get less and less and less, and then by the time it gets to the pump, hopefully you don't have much chips left, and then it goes to the filters. Obviously, there are two-stage filters, a 25 micron, and then a 5 micron filter, and then it goes back onto the spindle. It is not a coolant through the spindle setup, so even if you've got a little bit of chips left, it can only like affect your surface finish to a minimum extent. It's not going to wear out any of the mechanics of the machine. But obviously that's why we've got the two-stage filter, so hopefully nothing will get past that. And yeah, so the chips will get filtered here. Obviously you can access this whenever you want. You just like press a button, this goes up to a certain position, you pull this tray out, and then you've got access to these chip trays, and then you can just like remove the chips from here. So yeah, what else? I don't have another CNC at this moment. I might buy just a Chinese or a second-hand robo drill or something for the roughing at some point. But at the moment, I'll just probably send them out for roughing, and then because it's just way easier if you can get everything like pre-roughed and then just put it on this machine to do the finishing. But it all depends on the type of work that I can pick up. But no plans for a second machine at this point in time. I've got some prices for some like robo type RoboCAT, is it? The Fanuc one, yeah. Yeah, the Fanuc, like the rotary type magazine. VMCs, what are they called? Oh gosh, my memory is terrible. Robo drill, there we go, robo drill. Yeah, thanks for that. So yeah, robo drill machines. There are some Chinese copies with a similar turret type magazine for like peanuts, not much, and they've got the whole chip conveyor and everything. And yeah, so I can probably pick one of those up and then do your roughing on that one, and then put these parts on these pallets. You can probably use the same pallet changing system on that one as well. So I'll probably buy a System 3R chuck, put it on that. You fix your parts there, and then you load them there, do your roughing, and then just load them up on this machine. And obviously, probably your pallets, your roughing would be a lot quicker than your finishing. Why wouldn't you also do the roughing on this machine? Just curious. Okay. Yes, you can do your roughing, but obviously this is a 1.8 kilowatt spindle, 60,000 RPM. You can't remove a lot of material with this quickly. The idea of having a spindle like this is to be able to do more finishing, high-speed machining. Yes, you can do some roughing. So obviously the maximum tool diameter on this machine is 7 millimeters. It's an ER11, ER11, and the maximum diameter is 7 millimeters. So with 7 millimeters, you are quite limited to do roughing. Yes, this machine is designed to have like very fast acceleration. I don't know how much. I'm hoping to achieve around 1G. So with high acceleration, you can do poop, 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 very, very quickly going around it. And obviously, because of all the granites and all the preloaded linear guides, there shouldn't be any vibration or rattling or minimum vibration and shaking. So you can actually go around a part very, very quickly. But then you're wearing out the machine and the spindle bearings and the whole system. With that said, I think in the beginning, for, I don't know, the first 6 months, first year, I will do the roughing on this machine. But then as we progress, I'd probably buy an old CNC, put it next to it, and that would be a lot more efficient to do the roughing. And then you can just finalize the finishing on this one. But I have seen machines like Factory 5, which is by now belongs to the Chiron group. They do roughing on those machines. Obviously, Kern, they've got I've seen people doing roughing on the Kern Evos, which is is it the Kern Evo? Yeah, I think it's the Kern Evo, which is sort of their old version before the Micro HD family or the Micro family. And people were using some tools to do some roughing on those machines. Those are a lot slower than this one, but I've seen people doing some roughing on them as well. Okay. Any more questions? Oh, we've been going on for 40 minutes. Yeah, I will add some LEDs behind this just to show like the status of the machine, like if it's in idle, if it's running, and that sort of thing. The camera feed can be streamed on the internet, so you can have like visuals inside. Obviously, inside will be filled with LED lights all the way around, so you've got like maximum visibility of everything. For finding the actual center of a part, yes, I will have a probe, but sometimes you need some visuals. There are some systems like with a microscope or a lens that is mounted on the center of the spindle. I might do something with them, some experiments, but these are just like plans in the future. Maybe adding a camera here as a tool, so you can pick it up and then plug it in manually, and then you can like see the feed, or even a wireless camera with a little battery that you can pick up and then find the center of the spindle with an offset that you've done once. Yeah, these are some of the plans. Oh, this chuck needs to come a little bit forward because now with this swing arm and everything, it can't physically reach to that level. So I just need to bring it a little bit forward to be in line with the spindle, which isn't a problem. I've just drilled some holes in this table. I just need to drill more holes with the machine itself and then tap them and then just bring this chuck a little bit forward, and then job's done. So yeah, that's one thing that needs to change. Right, I think I've showed you everything which is new. I did say a linear stage will go somewhere around here eventually, which is pretty straightforward, and then some ropes to pull this, steel wire ropes to pull this up and down. Yeah, what else? This will get picked up. Do you intend to try some guilloche? Yes, definitely. So guilloche, yes, because it's this spindle is got this one specifically got an encoder, so you can run it as a position controlled servo, and because it's water cooled, it should be able to hold its position without getting like too hot. And I am driving this spindle with one of the Beckhoff drives themselves. So the whole idea behind this was to pick up a tool and then actually use the tool to do some guilloche patterning on the parts. So yes, it will do that in theory. If it doesn't, then I need to have like a tangential axis that goes around this, which I will either mount them on the on this system, which is the turning tool holders, or I will mount it around the spindle for doing some guilloche. But I think it will be able to withstand all of those forces for guilloche, because a tool is only like dead center of the spindle itself, and the amount of force that you're applying is minimal. So, and this one is 1.8 kilowatts, so it should be able to hold its position firmly. Nicholas from NH Micro has achieved some pretty cool results. Yeah, I saw their results. Yeah, I think you mean Josh, but yeah, his son. But yes, he commented on how he had hacked the machine to get. Yeah, yeah, yeah. I do listen to their podcast every now and then. Yeah, that's quite interesting. Yeah, Josh is quite talented, and his dad as well. He's a very genuinely a good guy too. So shout out to him. I've talked to him on a few occasions, and yeah, he's pretty good. Um, yeah. So yeah, hopefully GeoShare tapping again. Beckhoff. So mm, I mean, this is a rabbit hole, really. But Beckhoff, I think it's a good option because it's quite open source. So if you want to do those hacks into the system, you've got full access if you're using Beckhoff. And there's this company called ISG, which has written the interface for TwinCAT CNC. I don't think originally Beckhoff have developed the CNC part of TwinCAT. I think it was done by ISG, and then ISG, I don't know what was the arrangements, but Beckhoff now has added the CNC package on their system. And it's got loads and loads of different types of compensation things that you might need for this type of machine. So you've got, for example, positional compensation, volumetric compensation, thermal compensation. So there's quite a lot of things that you might need to achieve to a high degree of accuracy. Yeah, it's one thing for your machine to be mechanically accurate, but if you want to achieve the maximum accuracy, you need to have yes, you need to have some level of software compensation. So yeah, I've done my best to have like absolute perpendicularity between the X and the Y and the Y and the Z axis, but we are talking about stacking of tolerances. So when you've got stack of tolerances, there's so much you can do, and after that you've got like 2-3 microns of error, and it's with those positional compensations on the software side that you can achieve absolute or the best accurate and repeatable results. So Beckhoff's got all of that already baked in. So that's one of the reasons. And then the other one is scalability. So if you're limited, if I went for like a control that was quite limited, I couldn't simply just add another servo and then have like a pallet pool system. And this obviously needs to be coded into the system. So this is with Beckhoff that with peace of mind, I can say, okay, today I'm going to add a pallet pool. Tomorrow I'm going to add a secondary tool changing magazine, which is a linear, for example, magazine. If I've got, if I have like, if I need more tools, or if I want to do something crazy, or have like a second machine next to it, or whatever, I can easily extend and sort of expand the system with Beckhoff. I want to have like 2 monitors. I want to have 3 monitors. I want to have like different types of things, and that's why I went with Beckhoff, because of the scalability. Yeah, that's a good question. So this is by a company called PanelMate. It's a Chinese manufacturer. They've got this version either wireless or they've got it hardwired, and so that you can have like the both versions. The reason I went for it is this one is the hardwired, but you can see there's a symbol for battery here, and also a symbol for signal. They've got this version with a wireless connection as well, and it's good because it's EtherCAT. So it's EtherCAT based. There's a little device that goes inside your control cabinet, and that's your EtherCAT like receiver, and then just plug it in, and then job done. So it's by this company called PanelMate. It's not cheap. It is quite expensive because it is EtherCAT. So I had 2 options: either buy another I/O card, put it next to what's its name, the controller, and then map all of these keys, and then wire the encoder also back there, and have it like so, or use this EtherCAT version. I have not purchased this yet. I might still do that because I've got an encoder card for the back off. So I've got one extra encoder input available for the MPG, and then these are just some IOs. So I might do that. I may not. It depends on the price. I'm not really too precious. You can buy loads of MPGs cheaply from AliExpress. There are wireless ones, so you can buy one of the wireless ones, and then you've got a few IOs like for these keys and selectors and what have you. And then you've got the MPG, which is just an encoder, and I've got the card for it. So I might do that. I might use this one. Any more questions? I think I mentioned about the brand of these screens called Iyama, IYAMA. Japanese company. Yeah, pretty good stuff. Yeah, okay. I don't think there's any more. Do you expect the machine to be more precise than a commercial machine of similar size? Oh yeah, that's a tricky one. I had it. I can't. Can I say this? Well, I will not say this because they might be watching. But how to explain this? Yeah. Okay. So there are certain machines on the market that are quite accurate machines. There's only a few manufacturers in the world that can like really say that they've got super precision machines. There's 2 or 3 in Japan, and 2 or 3 in Switzerland, and 1 or 2 in Germany, and that's about it. I don't think there is one absolute most accurate machine in the world. There are some companies who claim that they've got that. I don't think that's the best way of saying things like that. I don't think it will be as accurate as or more precise than a commercial machine. But let's also compare apples to apples. I mean, let's say, for example, my budget now it's going up. Obviously, this enclosure itself with the panel and everything. Don't hold me onto this, but I think it's going to cost me about £10,000, which is a lot. But when you put the whole budget together, it's £60,000-70,000 or £80,000 maximum. You can't compare it with a machine from Roku, which is £700,000, or a Kern, which is £600,000-700,000. So it's like 10 times cheaper than those machines. Will it be as accurate? I hope so. I hope to get to a very, very similar accuracy, like within a couple of microns. And hopefully with the things that I've built around it, I've narrowed it down to get to those levels of accuracies and also get it repeatable over time. But there are some limitations. If I had like immense amount of electrical power, I would have never used bolt screws. I would have gone for linear guideways. If I had loads of power, I would have used linear motors. I said linear guideways, linear motors. If I had like in the best case scenario, I would have used hydrostatics rather than linear guideways. But I don't have those luxuries because they use a lot of power. Even just by using the torque motors, I'm still unsure if I can have like enough power to use the machine to the level I want. But yeah, that you can't really compare this one to a commercially available machine. And also, this looks like a Frankenstein. It can do everything. Like on a Kern, you've got like a palletizing robotic thing that comes out and picks the pallet up and takes it to a pallet pool, and it's all nicely done within like a different cell. And yeah, it's a different setup, it's a different use case. For a DIY, something you build in your garage, I think this is as good as it can get. But for commercially, I don't think so. I think if I had loads of money and I wanted to start a machine shop, I would have bought it at Raku or a Kern. So that's my answer. How is it to how easy is it to set up the TwinCAT control, assuming you're not doing something super special? Is the setup fairly UI, but to be an expert? No idea. This is the one gray area. I've had a few meetings with people at Beckhoff. I'm fairly good with computers myself. I've done some programming. When I went to uni, I first started as a computer engineer, but then changed to mechanical engineering. So I've got some base of computer programming and engineering. I might outsource it and find someone to do it. I know that there is like an interface which is like very similar to this, which is very, very similar to the Siemens interface. If you've used like 840D or the C-numeric one, it's very similar to that, but I'm not sure how ready out of the box it is. Yeah, so that's one gray area that I'm not really sure about. Yes, I would say hopefully it will be a winner in precision per dollar. Yes. Rough number of how much it costs to integrate a TwinCAT on a machine like this. This is about 5%. How much is it? Yeah, I can tell you. I mean, I purchased the computer that they recommended, which is a Core i5 computer. It was over £2,000 just the computer itself. Then you need to have servos. I bought the servos from themselves, which is very expensive. You don't have to do that. You can buy you can buy the servos from any manufacturer, even Chinese ones, which are quite cheap, really, or Delta, which is a good Taiwanese brand. And as long as they are EtherCAT ready, then that's it. So the only thing you need is the computer. You can actually use any other computer which has got an Intel Ethernet chip, but they said that for the best real-time performance, you need to use their system, which controls the Ethernet chip at the BIOS level, and also the Windows is real-time and blah, blah, blah. That's why I bought that. And then to have the best integration, I just went everything back off. Maybe it was a little bit crazy at the time. I didn't design the enclosure back then, so I didn't know that how costly it would be. So I threw all of my money at Beckhoff, and now I'm just like in that rabbit hole. I can't get out really. But yeah, I'm glad I did it. The quality and everything is just fantastic German stuff. So yeah, you don't need to. The only thing you need is just the computer box, which starts from £700-800 or $1,000 or something like that to $2,000-4,000. And then once you've got that, everything else you can buy it from China, as long as it's EtherCAT ready. Rokus are fantastic machines. Otherwise, thank you very much. Appreciate it. Hello from America, American, Lebanese. Are you Middle Eastern? Yes, I'm Persian. Yeah. If you came a bit earlier, I was speaking in Farsi. Yeah, I don't know the timing. I looked at different timelines, time zones rather. I saw like on the west coast of America, it's like quite early in the morning, like maybe 10 o'clock in the morning or something. And then East Coast was, I don't know, maybe just lunchtime, just after lunchtime. And then Europe is like 6-7 o'clock. And then I've got a lot of friends back in Iran, and then they're like 10:30, or now it's about 11:30 back home. So I hope I've picked a good sort of time zone that suits everybody. We've got 24 people online, 25 people online now. So yeah, it's good to have you guys, and really appreciate your support for the project. It gives me really gives me a lot of enthusiasm for the build. And yeah, so appreciate your support and all the comments and everything, and just keep them coming. Hopefully I will make more videos. I'm still waiting on a few parts to be manufactured. That's why I haven't really uploaded anything, because I'm still waiting for a few critical parts for the A and the C axis. The body and everything is manufactured, but there's like cooling jackets and everything which is still missing. Hopefully they will arrive soon. And then the sheet metal is done. I need to now send it for laser cut, and then bending and folding and welding and what have you. So once that's done, then everything else can be mounted. I don't think I'm going to make the enclosure in this current place. So I will probably move to somewhere else. Maybe I rent a place or a bigger garage or something, because the enclosure just simply doesn't fit in my garage at this stage. So that will be probably 6 months down the line. But hopefully in the next 6 months, the machine will be up and running, and we can see it moving and cutting and doing some stuff. And then once we've got the enclosure and everything around it, then we can just like seriously get into part production. Yeah, I got the lab parts from China. So granite manufacturers who make frames for CMM machines. So there's quite a few companies. There's one, the one that I used is called Unparalleled, which is quite an ironic name for a company that is trying to make parallel things. So it's called Unparalleled. You can search them, just Google Unparalleled Granite, and it will come up. Almost like VMC for lapping on these machines. No. So what these guys do is they grind it first, and then they lap it manually. So there's like people just like lapping it manually on bigger granite plates. So no, I've never seen any machine. Yes, there are lapping machines, and you probably can make some sort of machine for this. There are lapping machines which like they've got small discs that go around. You put your part in, and then you put your lapping plate on top, and with its own weight, it'll just like float, and then you've got constant flow of water. But those are for making like small lenses and small parts. Nothing that is like every single part is different. And those are for making flats and maximum parallel, say, faces, not anything that is 90-degree perpendicular. So that's for something like that, you need to have a lot of fixtures, and it's a manual process. Yeah. Okay, we've hit the 1 hour mark. I think it should be enough for today. Thanks everyone for joining in. And yeah, please keep the comments coming. And if you're watching this at a later date, you can still leave your comments down below, because I'm going to save this video. So leave your comment down below. I will come and answer the comments to the best of my abilities. And I hope to catch you in the next one. Appreciate it. Cheers.